All right, good morning. This is Jeff Scott. It is Monday, the 3rd of October, 2022. The class is AWD 1100 C# programming, and we are in day 30. Hopefully what you can see on your screen right now. All right, good morning, Grant. Hopefully what everybody can see on their screen right now then is the email I sent out to you about an hour ago. All right, and I just want to very quickly go over it. And as it says here, today I'm going to lecture on chapter 11. My guess is that we will be done probably within an hour. All right. After we get done with that, I want to go over the work that is going to actually be due for chapters 9, 10, and 11. You will have 2 lab days this week. All right. Tomorrow, we're going to go over half of the problems that you're being assigned. Okay, Wednesday will be lab for the entire period, so will Friday. On Thursday, I'll go over the pretest that I've created for you, and it's a little different than all the pretests you've done previously. I'll email that pretest out to you by Wednesday. And as always on Thursday, then we'll start a little later. I'll start up at 9:30. It's just one problem. All right. Friday again will be a lab. So Wednesday and Friday, since they're labs for the entire period, there won't be any taping. A week from today will be Hot 5, hands-on test number 5 for chapters 9, 10, and 11. I will tell you right now, there's nothing on chapter 11 that we're going to go over today. Nothing on it on your test next Monday on your hands-on test. Not a thing. But we're going over this for completeness. All right. Now, this isn't on your email that's right here, but I do want to mention to people. So a week from today, we will have Hot 5, chapters 9, 10, and 11, really 9 and 10. Then on Tuesday, what I'm going to do on next week is I'm going to go over chapter 17. So I'm going a little bit out of order here. For now, we're going to skip chapters 12, 13, 14, 15, and 16. I want to go over chapter 17 because it's on how to use files, and it talks about data persistence. In other words, everything we've done thus far, you run a program, and as soon as you stop your run, all that data, anything that you've created, anything that etc., it's all lost. So what we're going to do on Tuesday of next week is we're going to go over chapter 17. And I don't know how long that'll take, 1 hour, 2 hours, whatever. Then we're going to start to build an application, a complete payroll application that we're going to create as a class. I'm going to get it to a certain point with you, and then I'm going to ask that you finish it up. Don't worry about that right now. I have not written it yet, so there's really no more about it than I can say at this point. All right. And also, after I lecture today, we will go over then the work that will be due this coming Sunday, the 9th of October. All right. So with that said, let me change my share here. And I'm going to go back to the internet, and we're going to start going over chapter 11. Now, hopefully what you see on your screen right now is you see a screenshot or whatever you want to call it of your textbook. All right. So when you look on here, after today, we've done all of section 1. We've done all of section 2. So in other words, in 30 days, we've completed half the book. As you'd probably guess, the other half of the book is more complex, especially, again, chapters 12 through 16. Now, when we go through chapters 12 through 16, and I think I mentioned this to you before, but I'm just saying it right now, I'm going to concentrate on chapter 12, chapter 14, and chapter 16. All right, I'm not even sure if I will lecture on 13 and 15. I guess we'll see as we go on. All right. But with that said, then I want to jump right into chapter 11, which is on debugging. There will be material that's in here that you'll say, we already went through that, and we did. All right. But this is looking at debugging in much more depth and breadth of coverage than we did. All right. And again, some of the stuff that's in here, I'll be honest with you, there's stuff that's mentioned in this chapter that I rarely, if ever, use. So if you say, well, what about this? What about this? I'll give you what I can on this. All right. As they mention here, as your applications get more complicated, debugging gets more complicated. All right. It says debugging is often one of the most difficult and time-consuming phases of programming, and it's true. Now, as they mentioned, their Visual Studio does have a lot of debugging tools, but sometimes the hardest part is just realizing that you have made errors in your code. All right, so they break it down into just two sections here: basic debugging techniques and how to use the debugging windows. There's one thing you have to realize, and I guess they'll get into it in here, but I want to say it before we even get too far in here, and that is the following. There are three types of errors you can make in a computer program. All right, especially like in a C# program. The first kind are the easiest because they're compile time errors. Probably every person watching this video at one time or another has failed to put a semicolon on the end of an executable line. And you get the little red squigglies, and you get a message in your error window on the bottom of the screen. All right, that's a syntax error. You are breaking the rules of the language. Just as in English, when you look at your book, what is your book? Your book is a series of sections that's broken down into a series of chapters, that's broken down into a series of pages, that's broken down into a series of paragraphs, that's broken down into a series of sentences, that's broken down into a series of words, that's broken down into a series of letters. All right. So, but every time you go and read a page, and I've given you examples like this before. This says right here how to work in break mode. All right, and everybody can understand what that means. But if they had basically reversed it and said mode break in work to how, it wouldn't make much sense, because in many ways you'd be violating the rules of English syntax. All right, well, in much the same way, a syntax error means that the system is expecting you to write code in a certain way and you didn't do that. If again, forgetting a semicolon is a thing we often do. If you ever put to string in there and you leave the R off and you write to sting, the system doesn't know what you mean. So those are the simplest type of errors because they're called syntax errors, but the compiler finds them for you. The next type, and you're going to see this in just a minute because I'm going to build a really simple application to demo some of this stuff. And that is when you've got runtime errors. Runtime errors do not stop your program from compiling like syntax errors do, but when you run the program, oftentimes they'll make your program just blow up. And we've done things like divide by zero, when we looked a little bit at arrays, about having an array index that's out of bounds, etc. And the last type of error are they're probably the hardest type to find because they're logic errors. And none of us want to admit that we meant to do one thing and we did another thing. All right, so we'll look at all those. But as it says, for the basic debugging techniques, we'll talk about the debugging options, working in break mode, using edit and continue, the data tips that come with Visual Studio, breakpoints, and I've already shown you some of that stuff, controlling execution of an application. That's about the first 10 pages. And then the last 15 or so pages talk about the locals window, the autos window, the watch window, the immediate window. So we'll look at those. The call stack window, the call hierarchy, the output window. All right. So basic debugging techniques. All right. Well, one thing is every time you run your program, in essence, you're testing it. All right. And some weird thing might happen that you had never accounted for before. Now, I'm going to try to keep this down to 2 minutes, but I'm going to give you a very quick story. I have an older brother who worked at an air filter corporation. He was a comptroller for an air filter corporation. They used this operating system I'd never heard of before that was called PIC, P-I-C. Well, they decided after he had been working there 5 or 6 years, they were going to change everything over to PIC, and they did. And one day, one of the data entry people was having problems entering information into PIC, and so she grabbed. They didn't have any online documentation. They gave them manuals. So she grabbed a manual from the shelf, and when she did, it fell down and it hit the keyboard. It didn't really seem like anything had happened until a couple days later when they realized that she had removed a couple of their customers from their database. All right. And basically all I'm getting to in here is no one who had come up with that PIC operating system had accounted for a really, really weird keyboard combination with a manual falling onto a keyboard. So they hadn't accounted for that. So, luckily that company backed up their database every day. So they were able to go and fix what was there. But the point is, again, every time you run a program, you are indeed testing it. So when we look at some of the stuff that's in here, now this is the options dialog box. And if you bring this up, it's under tools options, you'll notice that there is a debugging right here. And they've got a bunch of stuff that you can set up. I will tell you that probably 99.999% of the time, I don't touch this. In other words, whatever the default settings are seem to work okay. But if you do need to get in and set something special, you can go in and do that there. The exceptions setting window, all right, says basically, we'll talk about it. We're going to take a look at some of this stuff in just a couple minutes. I'm not trying to not talk about it now, but it's easier to show it to you. All right. All right. There are 3 different modes that you can be in a Visual Studio C# program. When you are sitting there and you're either writing code or you're building your interface, all right, so if you've got a GUI app and you're building your interface, or you've got either a GUI app or a console app and you're just writing code, you're in design mode. All right. Nothing can happen. The program can't stop even if you make mistakes because you're not running it. Once you run a program, you're in run mode. If everything goes as expected, you go through the program run, you do what it is you want to do, and boom, you're done. But that's not typically how life works, especially as programs, again, get more complex. Then the chances are better and better that somewhere along the line, you're going to have forgotten to do something or you did something incorrectly. So you will enter break mode. When you're in break mode, as it says there, the system has encountered an exception that you did not handle in your program. That's typically how you get into break mode. They'll show you in just a minute, there's other ways that you can get in as well. All right. And you've seen this kind of thing before. So for example, if I try to divide by 0, it'll come up with a divide by 0 exception. It'll highlight in the code where the error was, and it'll give me a chance to get a little bit of an explanation as to what's going on. All right. Now, one thing that's fairly unique about Visual Studio, when they talk here about edit and continue, you can typically, as your program's running, you can actually do some debugging. In other words, you can go in and change values as the program's running, and you can do other things like that. Now, would I recommend that? It depends on what you're doing. All right, but as it says here on the bottom of page 344, the edit and continue features allow you to make changes to code while you're in break mode. and continue to run the application. As it says there, if you realize you screwed up on a calculation, you can enter break mode, fix it, and continue running. Some people like that. Some people are like, you know what, as soon as the program breaks, I just want to get out of it. I know what the problem was. I want to go back into design mode and fix it and then run it again. All right, but again, you don't have to if you don't want to. So again, you've seen this kind of thing before. All right, in fact, we've seen this one a lot, this format exception, where it comes up and it says input string was not in a correct format. So again, they're expecting a decimal, and if you either leave it empty or you put something non-numeric, that's what's going to happen. And you'll notice below the error there, your screen is split into a couple directions. And you've got what's called a locals window, and you've got what's called a call stack window. In the locals window, it shows you all, in the current routine you're in, it shows you all the variables that are in there and the value of those variables. In the call stack window, it's trying to show you, it says, hey, the last thing that ran that caused this error was over here. The thing that called that was over here. And sometimes with a call stack window, all right, it might show 5, 6, 7 or more routines. This, call this, call this, call this, etc. It always shows it does that in a LIFO order. If you remember, we talked about LIFO, last in, first out. So it will show you the last method to be called, then the one that called that, then the one that called that, etc. And that's literally typically referred to as unwinding the stack. All right. Again, as it says here, there are 4 different ways that you can basically enter break mode. All right. You can force an exception to happen that you don't handle. You can set a breakpoint. You can do a debug step into. Now on this, what it's saying right here is when you want to step into it, that means you want to run your code a line at a time. You can either press the F11 key up on the top of your keyboard, or you can choose debug step into. Now, I always use debug step into just because of the fact if I hit F11, sometimes it does weird things when I'm in Teams or in other things where I'm actually taping. So I always do the debug step into. And it says you can also do a debug break all to put yourself in there. So the key thing is what it says here. If you have an exception, so if something goes wrong that you have not accounted for, Visual Studio takes over. It enters break mode. It displays that exception helper that we talked about up here. So that's the helper. All right. And it highlights the statement, the last one to run. Okay, now it is possible that that's not the one that caused the error. It might have been something was defined incorrectly up above, but it's showing you where it broke, for lack of better words. Again, there's an edit and continue. As it says, it lets you make changes while you're in break mode. And typically to exit break mode, you click on the stop debugging button in the debug toolbar, or you choose debug stop from the menu. All right. Now, with some people really, can take a look at this, and in this example that's right here, let me go back one. Again, this is a data tip right here, but you've got 3 options. You can view the details, which will show you a little bit more in-depth stuff. You can copy the details. Why would you want to do that? Well, if you've got a really long error message or you keep getting an error message, you might just want to copy it to a Windows file and then go Google the message. This start a live share session, I've never tried that, so I can't really say anything about it. All right. Now, when you're doing this, right here, technically at least, line 22 is the line that's in error as far as the system is concerned. The reason I'm telling you this is line 22 did not execute. There was something in it that made it blow up. Since 22 did not execute, neither did 23 or 24, et cetera, et cetera. So nothing below it executed. Now, if you look here and you click on that more information or whatever, one of those things, you can see this will change the stuff that's in the exception helper. That may or may not help. Typically, you look in here, you look at the message and, oh, that's what I did. Or you come over here to your locals window and you start looking at the value of variables and you can figure out what happened. All right. But again, everybody's different in the way they run this stuff. All right. Breakpoints we've talked about before. This area that's right down here, this gray area, it's known as the gutter area. If you click on an executable line of code, it'll put a little cyan colored dot in there. You can set as many breakpoints as you want. When the system gets to that line of code, it will stop. In other words, it'll put you into break mode. All right. And you can take a look at the values of code that was above it, etc. And there are other things you can do, and you're going to see these in just a couple minutes. All right, so as it says, to set a breakpoint, that's the easiest way. It says you can press the F9 key so you can be on a line, hit the F9 key. I don't do that. To remove it, you remove it the same way you set it up. So you click right there to turn it on, you click again, and it turns it off. There's also on the debug menu, if you've got a lot of breakpoints, you can disable all of them or enable all of them at one time. Notice in the description here, you can only set a breakpoint on a line that contains an executable statement, which means, for example, you can't set it on a blank line or a line with a comment. Typically, it's got to be on either on a loop or on a line that ends with a semicolon. All right, I think we've covered most of the rest of the stuff that's there. How to control the execution of an application. This is the key page in the whole chapter is 351. This chart that's right here tells you how you can either use keyboard options or toolbar options to go through. So let's talk real quickly about what each one of these are. If you set a breakpoint because you want to see what the value is of a certain variable at a certain point in the program, and you enter break mode and you look at it, okay, now I want to continue. You click just like you do when we want to run the program. You click the green continue button, or you can hit F5, and that'll continue execution. If you click this blue thing, and I don't do that, maybe you do or have, or do a Control-Alt break, as it says, that suspends program execution. Why might you want to do that? Well, you get stuck into an infinite loop somehow. You do something accidentally and the program is spinning out of control. Typically, the first thing you'll try to do is click the stop debugging, and normally that will get you out. But if it doesn't, you might want to try the blue one here that says break all. All right. Restart. So if the program is running and maybe it stopped because you put a breakpoint there, now you fixed it, but you want it to run again from the beginning. So you can do a restart. Show next statement. As it says, what that will do is it'll show you what's going to happen next. The three that I end up using the most are the three that are shown here. And really the one I use the most is the F11 key. Because as it says, it allows you to execute one statement at a time. So there is an icon for it, there is a function key for it, or you can choose from the menu debug, step into, debug, step over, or debug, step out. All right. So the step over says execute a statement at a time except for called methods. So basically it'll jump right into a method is what they're saying here. Step out can be very important. If I put a breakpoint inside of a loop, let's say inside of a for loop, all right, and that for loop was designed to run 1,000 times, I wouldn't want to have to keep hitting F11 1,000 times. That would be silly. Maybe I only want to run through it 4 or 5 times to make sure it's working, and then I want to get the heck out of it. So I could use the step out to do that. Another one that's fairly important here is the run to cursor. All right, because what you can do with the run to cursor is you can put your cursor on a certain line of the program and you can tell it to execute until it reaches that point, and then you could tell it to stop. It's very similar to setting a breakpoint right there. And again, the set next statement says, set the statement that contains where you want to go next if you are in break mode or whatever. So this is just kind of a reiteration of what I've told you. Okay, all right. The debugging windows, as it says in here, we first have a locals window, as you can see, and you can expand this window, but the locals window shows everything that's available to you inside of the method you're currently in. The reason I'm telling you that is there is a locals window. There is also something called a watch window. And the watch window you can set and look at and check out the value of values throughout the whole program in one window. But especially if you've got a very intricate thing like they're showing here, you can run through it. And with this example that they're showing right here, what they're assuming is as you're running through this program that's trying to figure out future value, that somehow it's not breaking, but you're getting a really god-awful number that's way too big. I mean, for instance, if you come in there and you say that you want to invest $1,000 a month for 5 years, well, then the number of months would be 60. So you would loop through this 60 times. But if it's $1,000, even if you do it every month for 60 months, that's $60,000. And you got to look at it that let's say you're getting a 2 or 3% return. All right. Maybe you'll even have $100,000 by that time or something like that. But if you do it and you get a number in the millions or the billions, well, something's wrong. So you can go through this in your locals window and have a look in here, and then maybe it'll help you figure out what went wrong. So as far as using it, as it says to display it, you can click on the locals tab or do a debug Windows local. All right. There is an autos window, as they mentioned, says it works like the locals window, but it only displays information about variables that are used from the current statement and the one before that. Again, you can do a debug Windows autos command too. All right. I already mentioned to you that there's also a watch window. And again, the locals window is designed for you to be able to see the value of local variables. Local variables that are local to the method or function you are currently working on. Sometimes that's not enough. You want to be able to see everything that's happening through the entire program. All right. So in that case, quite often you would use the watch window for that. And you can add watches in your program. All right. And what that'll do is in this watch window, anything that you've added watches for, it'll watch for that. All right. In other words, as the program's running, you can look in that window to see that value changing. That again can be very helpful. All right. And the funny thing is, and I'm probably as guilty of it as anybody else, that most people debugging programs scares the hell out of them because there's so much to look at and do, etc. But again, the idea is if you are creating software for someone, you're working for a company that's creating software for someone, or you've got your own business and you're creating, you want to find the errors. You don't want to release software to somebody and have them find errors. It's much easier and it's much cheaper for you to find the errors. All right. Let's continue on then. How to use the immediate window to execute commands. This is kind of a cool thing. All right. You can open up an immediate window over here. And what's kind of neat about it, you may or may not be able to tell from the picture here. But for instance, you can type in the name of a control like txt interest rate.txt and hit enter. And even though your program's running here, it'll show you its current value. All right. You can even do math in there. So in other words, if you were running a program and you thought to yourself, man, I'm getting weird output, you could do mathematical operations in here if you want to. But most of the time it's used because people put in a question mark followed by something they want to see the current value of. And again, that's referred to as the immediate window. All right, how to use the call stack window to monitor called methods. We already talked about the call stack. It's shown in here. So this is where it found an error. This is what called that routine. This is what called that routine. All right, so you can open that up. And again, all they're trying to show you in here is that sometimes, at least, as you iterate and work your way through here, sometimes this can really help to figure out what the problem was and where the problem was. So as it says, you can use your call hierarchy window to iterate your way through here. As they mentioned, it displays calls to the methods, properties, etc. that you select. How to use the output window to view project information. That's down here. This is the window that comes up by default. You may or may not have seen it. All right. Now, with what we're doing in this class, what I'm about to tell you doesn't really mean much. But when you are taking the class in your 4th semester, all right, that class used to be a class where we would go over and build Android applications. But instead, what we're changing and converting that class into is writing C# related web applications. And when you run the C# web applications, you end up a lot of times having to set up a lot of things on your computer as right before you run the program. So quite often you come down into this output window and you type stuff in there. But for us, the output window is used basically to show you whether or not you had errors, for lack of better words. It shows you different build type of information. All right, again, you can write data out there, as I mentioned. I'm not going to go through that anymore right now. And believe it or not, we're almost at the end here, but they talk about using this visualizer dialog boxes to view strings. Not going to lie to you, I don't know if I've ever used this before, but they mentioned Visual Studio includes some dialog boxes that you can use to display the string in a way that's easy for you to visualize. Most of us, when we look at strings, you want to look at them like this. But if you notice in here, there's other ways that you can look at them. All right. If you are writing a web-based C# application, you might want to see this in HTML. All right. XML is the extensible markup language. Back in the 90s, people said that HTML was dead and they needed something else. So somebody came up with the idea of this extensible markup language, XML. The main difference between XML and HTML is in XML, you make up your own tags. Well, it's still used, and there are probably several hundred different dialects of XML. But it was always considered kind of clunky to use. And that's one of the reasons that, really in the early 2000s, people came back, and that's when HTML5 was created. All right, the other one that's in there is JSON, which is JavaScript Object Notation. You use that a lot in your second year classes, both in the AWD1111 class, which is entitled Database Driven Website Development, and the one you take 4th semester, AWD1112, which is hopefully in the process right now of being renamed. The AWD1111 is going to be going to a name change from Database Driven Website Development. It's now going to be called Database Driven Website Development 1. And then the one you take in the fourth semester, AWD1112, is hopefully going to be being renamed to Database-Driven Website Development 2. All right. So they show you in here how you can set it up. And again, there it is. You're seeing it as strings, but there's other ways that you can show it as well. All right, and that's it. So what I'm going to do, and I'll try to finish this up by 9 o'clock, and maybe we'll even be done earlier. I don't know. But I'm going to come in here, and you won't see this for just a second, but I'm going to come in and very quickly just come in here, and I'm going to create, sorry, I've got so much stuff open here, a new folder, and I'm just going to call it CH11, period. Then I'm going into Visual Studio here, and I'm going to create a new project. It will be a Windows Forms app so you can see what's going on. And I'm going to call this CH11 calculator. And the name of my solution will be just CH11. All right, so I've got that, and I'm going to click create. So once this comes up, there it is. I'm going to change my share. And for the rest of the period today, like I said, we'll be done by 9, I believe. All right. And then we'll take a short break, and then I'm going to spend about 15 minutes going over in detail what we're going to be doing tomorrow and what is going to be due from this chapter, because there's a lot of the stuff in the chapter I don't want us to do. All right. A lot of those homeworks and exercises. All right. So let me jump in here. Hopefully you can see on your screen right now, you can see Visual Studio. And if for some reason you cannot, please send me a message. All right. But I'm going to quickly set up something here. So I'm going to change the name of my form. It is now FRM calculator. All right. As I always do, I will come in here and make a couple superficial changes here. So let's change the back color. I feel like green this morning would be good. There you go. And I will change the text on here to just say Chapter 11 Calculator Program. Okay, now that should be showing. There it is. Okay, and finally, I'm going to make this, and it's going to be fairly simplistic. It's going to be very similar to stuff we've done before. So I'm going to come in, and first I'm going to throw up our 3 buttons. So this will be our calculate, our clear, and and our exit buttons. All right, that looks fine as far as I can tell. I'm going to move it down just in case I need it a little bit. And then I'm going to make 3 text boxes. So here is the first one. Make it nice and big, a lot bigger than it needs to be, but that's fine. Here will be my second one, and here will be my third one. In fact, I'm going to move these 2 down. All right, and I'm going to put in a drop-down list here, which is our combo box that we were just been learning about. There that is. All right, oops. Yeah, I didn't want to do that, but that's okay. We'll fix that later. So we've got that. All right. And then I need my 4. I want 4 labels. And then we'll be set to go here. So we bring up the first label. There it is. As always, make this a little darker. Go to the auto size and set that to false. All right. And as always, I'm just going to highlight all of this, change the size, etc. on it. So this will be 20, bold, Arial. All right, so we've got all that. Come in here and do what we normally do in here. Just prettying up the interface a little bit. I think already it will be just fine, so I can lock it into place already. All right, so that's done. This is going to be LBL number 1, and the text on it is going to be number 1. This will be TXT number 1. You get the idea. So this is going to end up being the operation. So we will call this CBO operation. We will put here operation. So this will be LBL operation. And again, it will say operation. All right, next, this will be number 2. And it'll be called LBL number 2. This will be called TXT number 2. All right, and finally, this will be called TXT result. This will be LBL result. And it'll have in there for text result. Now, I don't care about lining this up, etc. It's fine the way it is. All right. This one will be our BTN calculate. And it will say calculate. This one will be our clear, and it will say clear. Oops. And again, I'm not going to take the time to go and write the clear routine and to write the exit, which we'll put here in just a second. I'm just setting it up like this for completeness. All right. And finally, this will be our exit. All right, interface built. So the only one we really care about in here, now let's set up our stuff that we usually set up. In other words, just let me set up the tab order. And like a good calculator, this one right here for our result, we will have the read only set to true. All right, so everything should be set now as far as I know. So we go into here. I'm not going to worry about modularizing this or anything. All right, but I'm going to come in here and I'm going to do this. I'm going to say, this purposely is going to blow up because I want to show you some of the stuff that's in here. So I'm going to say int num1 equals convert dot to int 32 txt number 1 dot text. Again, this is a terrible way to write this. I get it. Okay, so we've got number 1 and number 2. All right, and I'm going to say string op for the operation that equals CBO dot selected index. Okay, dot toString. That's fine. Okay, then I'm going to do a switch on op. And we'll make one more variable in here. That's going to hold the result. So we'll make that a double and we'll call it res for result. Okay, so we're going to have 4 operations in here. We're going to have a plus, Actually the plus, well, plus, minus, multiply, and divide. This will be 0. And for now, I'm just going to type in break. So we've got something in there. So we'll have a 1, we'll have a 2, we'll have a 3, we'll have a 4, and we'll even put in a default here. All right, we did a toString, and that's why it's breaking like this. So I'm not going to make that, I'm going to make that an int, which means I can just use the selected index. All right, so if it's a 1, I want to say result equals num1 plus num2. You've seen this kind of thing before. I realize this is really nothing new. I don't know what happened there. That should have been a res. That's why it's giving me the goofy stuff. So if it's a 1, it's going to be subtract. If it's a 2, it's going to be multiply. If it's a 3, it's going to be divide. I guess I can put one more in there for modulo. And finally, if it's a default, we'll just do a message box dot show that just says error somewhere. Bad input. And we will, again, as always, we will come in here and say message box dot buttons dot OK and message box icon dot error. All right, so we've got all that. And again, we'll put a break there. Okay, now this actually should work as long as I don't put bad stuff into it, unless I screw something up. So let's see if indeed it works or it doesn't work right now. All right, just because I'm a little anal about this stuff, I will come over to here and I'm going to set up just 2 things. That is, I'm going to set up my accept button. Remember, we're not even, right now, we're not even programming the clear button or the exit button. So the start position, I'll set at the center screen. Let's see if it works. And there's one more thing I forgot to do. So once we do that, and now we hopefully have got the result. All right, I'm going to change this to just return. All right, and once we get out of this switch statement, I'm going to say txt result.text equals res.toString, and we'll just do it n2. So 2 decimal places. All right, let me save that and run it now, and let's see what it looks like. Oh, there's going to be a problem. I haven't set anything up in here, so let me do that too. I forgot about that. My error. All right, so let me go back to here, and I'm going to come to here, and I'm going to go to my items, and we will put in there a plus sign, a minus sign, a multiply sign, a divide sign, and a modulo sign. Okay, that should fill up all those. Let's see if indeed it works right now. So 23 plus 4, 27. Looks like it works. 23 minus 4, 19. 23 times 4, 92. 23 divided by 4, 5.00. Well, I didn't account for the having a decimal place in there. It still is fine. Finally, 23 modulo 4, and we get 3. It looks like it's working. All right. But you'll notice that as soon as we run this, and my clear button isn't operational, but as soon as I come in here and as an example, I come in and I put a 0 in there and I choose either modulo or I choose divide, and I click calculate, I get an error. And there you go. So now you see my exception handler window. All right. So this is what I want to show you. Attempt to divide by 0. So it's a system divide by 0 exception. I can show the call stack, which down here in my screen is basically going to show me what called what in here. All right. And it even says it's on line 19 in main. All right. That something is goofed up in here. All right. I can also view more details, and this is showing me basically the equivalent of my watch window. So it's showing there is the error that came up. And if we dig our way through here, we can look through and try to find a bunch of other stuff to possibly use. Again, I can copy those details if I want to, or start a live share. And I've mentioned I've never done this before. All right, let me do 2 more things, then we'll take a break. We'll finish this up after the break. We will be done by 9:30. All right, there shouldn't be a problem with that. But if I come in here now, how do I start to fix this? Well, I could throw a divide by 0 exception, or I could just come in and say, if num2 is equal to 0, all right, I can do a message box dot show like we had here, and I can say illegal divide by 0. Boom. Illegal. Divide. All right. And then I can come in here and say, okay, what I want to do is I want to say txt result dot text is equal to just illegal divide. Illegal. Good golly. Divide. All right. And then I can return. Well, that'll fix that. Not only that, what probably would be a little bit easier to do would be to grab these lines of code, these things that are in here, grab that, cut it to the clipboard, come down here and put it down here. I'm going to call private void illegal divide by 0. And now I'll put that stuff in here. So illegal divide. Why is it giving me an error there? Maybe because I have a blank line. I don't know. So I've got here legal divide by 0. Legal divide. What doesn't it like? Close that. Close that. And that. And that. All right. And item to watch. I'm going to close that as well. Looks like it doesn't like something here. So legal divide by 0. Oh, it's telling me that I'm editing it while the program is running. All right. So as soon as I tell it to stop the run, it'll be fine. There we go. So if number is equal to 0, I'm going to do an illegal divide by 0, and I'm going to return. All right. And I'm going to do the same thing, the same if statement for modulo. Okay. Now, what have I done? I mean, have I fixed the program? No, and it even looks like there's something it doesn't like here. Still, illegal divide by 0. It's telling me new line and constant. Don't know what that means. Syntax error. It says semicolon expected. Message box dot show. There is our message. There is our title. Message box error. It all should be okay. I'm trying to figure out what it doesn't like here. What happens if I do this? Oh, I don't have an ending double quote. That's what it is. There we go. All right, so let's see if this starts to fix it. So if I come in here again and I put in 23 and a divide, you already saw it by 4, but if I put in a 0 now, all right, illegal divide by 0, and it says illegal divide. Good. And the same thing should happen. So let's just do here something that is valid. I'm going to do it again, but I'm going to do it with a modulo. So you can see I'm taking control. But if I didn't take control, you saw what happened. Now, rather than do this, and this is totally fine what I did. All right. But the other thing I could have done instead of writing this routine is I could have come in here and said, put a try statement in here. And I could have said, let's see, if it's equal to 0, what I could have done, I wouldn't even need a try. I could just have said throw a divide by 0 exception. And I have to put the word new in front of it. So throw a new divide by 0 exception. All right. So I could have done that. And I could have done that down here as well. All right. Then I would have had to have caught it someplace in my program. Okay. But I could have done the same thing. I think what I just showed you was easier, what we just did here. So we've handled that. So the only thing that's left to handle, and we're going to do that in just a moment, is to be able to put something non-numeric or leave it blank. It is 9:02. Let's take 10 minutes till 9:12, and we want to finish this up by 9:30. Okay. Be back in just a moment. All right, I'm back. Hope you're back too. Let's just quickly finish this up. Now, you probably have already realized this, but if I come in here and run the program again and put nothing in here, well, it blows up. Input string was in the wrong format. We get a system format exception. And again, most people will typically tell you that when they're doing this, it's much easier to solve this stuff without writing exception handling. All right, so what I'm going to do is I'm going to make another thing in here that I'm going to just say bool test, period. All right, now I want to come in here and I want to do this. Keep as much of this as I can. I'm going to say test equal integer dot, this it's in32 dot try parse. Try parse. What do I want to parse? This. Where do I want to put it? Into num1. All right. So I have not yet come in here and declared num1. So let me try that again. There. All right. So you know that I'm trying to take what was in here. So we'll just say here int num1. Okay. And I'm trying to take what was in there, get rid of this too, and do the conversion. All right, well, you know as well as I do that conversion's either going to fail or it's going to succeed. So if I come in here and say, if not test, then I can just come in and say what? Try that again. If not test, there we go. Again, we will just come in, we could write a message box like we did before here. And just come in here and say illegal conversion. All right. Bad input is fine. So that's going to cover if we come in and try to take and basically parse and put our stuff into num1. Well, if we do that, I guess the other thing we should probably do is to just say txt num1 dot text equals double quote and txt num1 dot focus. All right. So that'll handle that. But then we've got to do the same thing for the second one. All right. And after we do that, we'll just return. Now I'm going to grab everything I had right here, everything, and I'm going to copy it to the clipboard. And I'm going to paste it in. And now I'm going to say test equal. Now we're going to do number 2. All right. And that'll be a 2. And that'll be a 2. All right. So if we run the program again, it's almost done. So when I run this now, if I put nothing in here and I click, I get illegal conversion. It goes right back and tells me to do it again. If I put in something that's non-numeric, same thing, illegal conversion, and it goes back. Once I put in something here, the problem still is going to be with this. We don't have anything in here. All right. But notice it's going to jump down right away and say illegal conversion, and then now it puts it here. All right. So I've now got those two things handled. So what's left? Exactly what you think is left, and that's this. All right. So remember that when we put stuff in there, the plus sign was 0, the minus sign was 1, the multiply sign was 2, the divide sign was 3, and the modulo was 4. So if I put anything else in there, remember, if there's nothing selected in there, it's -1. All right. So why am I telling you that? Because we can handle that now in here. So if we get in here in our default, it should say error somewhere, which is kind of crummy to say. All right. So that's, if we put in something else, we'll just put down here illegal operation. Right? Illegal. And I'm going to also just come back in here again, and I'm going to say txt result.text equals illegal. That's it. All right. Then I'm going to say CBO operation dot focus, and I'm going to put the focus there. All right. So I'm going to save this. I've already shown you putting nothing in here, non-numeric, but I'm just going to put my numbers in again. Now I'm going to leave this blank. Illegal operation, and there's my cursor. All right, which is exactly what I'd want to have happen. And as soon as I put in something, boom, everything works. Now, why am I showing you that? Because what I'm showing you is how you can incrementally build this. There are many changes that could be made to this to be made better. What do I mean? What do I mean, rather? Well, when we come in here and we're testing this stuff, we're doing the same test here as we're doing here. So that should have been written as just one routine. All right. And, we could have used one of the routines that we had from page 213 in our Murach book. But all I'm trying to get across in here is debugging is crucial. Every time you run a program, you are testing it. Now, I think it handles everything. Could I be wrong? Of course I could. All right. But again, if we put something non-numeric, it's covered. If we leave it blank, it's covered. If we do this, now it jumps all the way through to the second one because the order in which we put these. So again, that's covered when we put in nothing. That's covered when we put in non-numeric. And once we put in a number, that's now covered if we put in nothing. And once we put in a value here, that's covered. In my opinion, could I be wrong again? Of course I could. All right. But we now have written a program that handles all of our error conditions. So I showed you a couple of them, the divide by zero exception and the format exception. All right. And how we could fix those, etc. All right. I'm not even going to put this out there. I don't think I have to. Any one of you who is interested, let me know, and I'd be happy to put this out there for you. But I don't know why it's anything we haven't already talked about. So let me do one last thing here. I'm going to change my share, and I'll have to change it, unfortunately, a few times in here. All right, so. All right. Now, oops, try that again. Brought the wrong thing up in the share, so I'll fix that. Let's see. There it is. Now, hopefully what you see on your screen right now, Grant, you're watching. If I'm wrong, send me a quick email. But this is from chapter 9. This is the labs, or these are the labs for chapter 9. And guess what? I don't want you to do any of them. None. Why? Because they all say create a class, which we haven't talked about yet. You don't have to do anything from the assignment or the thing that says ch9 underscore labs underscore from underscore book. You don't have to do any of these. None. All right. So let me close this, which will screw up the share, but I'll fix that right away. Chapter 10 has a part 1 and a part 2, and I don't remember which one I want to show you first. I'm going to show you part 2 first. So this is part 1. So let me change that and show you part 2. And again, you might be saying, well, why? You'll see why in about 15 seconds. All right. This thing that's called ch10 underscore p2 underscore new underscore labs. You don't have to do any of those. Why? Because again, they say create a class. We haven't talked about classes yet. What that means is you're going to have 3 lab problems and about 3 homework problems to work on. Okay, so let me close this and let me bring up the one that we're actually going to look at. I have to change my share again. Sorry, but I will do that in just a second. All right. So this is the one we will be working on. This one has one problem here that's called superhero database. We're going to build that tomorrow together. You still have to do this, but we will build it tomorrow together. All right. So again, from the thing that's called ch10 underscore labs underscore new, you will do lab 1 superhero database. You will also do lab 2 job database. But the good news for you is that's it. You don't have to do this clock. You don't have to do this search because we've done a bunch of those already, and we don't do the build labs. So the only labs that you will have to do for chapters 9, 10, and 11 are LB1, the superhero database, and I'm going to do this tomorrow if you want to code along, and LB2, the job database. That one I'm going to let you try on your own. All right. So that's it for the lab portion. So let me get off of here. Let me change my share one last time. And now I'm going to go to the homework. Hopefully, again, Grant, what you can see here now are the homeworks. All right. If we go back to the very beginning here, it says that we have 2 different homeworks for chapter 9, 3 different homeworks for chapter 10. Let's quickly go through those. This thing right here, this calculate the number of nights, this isn't that different from the one that you were assigned for last week. The difference is you are using dates and a little bit of date math. So if you subtract 213 from 216, you get 3. So I'm going to let you work on 9-1 by yourselves. All right. So 9-2. We are going to go through this one tomorrow. Again, you can code along if you like. You can just watch. When I go through work that you are being assigned, I do not put that out on a GitHub repo. I don't save it for you. So you can watch and code along with me, or bring it up and code along on your own at your leisure, so to speak. All right, then we get to chapter 10. There's a convert lengths. Then there's this process lunch order, and then they have you refine the process lunch order. What we will do tomorrow as a class is this one, this convert lengths. Now you might say, oh, geez, we've done that already. Yes, we have. But what you'll see, notice in here, it says meters to feet. All right. Then this changed to meters right here, and that changed to feet right there. But if instead of meters to feet, we had changed this to miles to kilometers, then this must say miles, this must say kilometers. So we were going to go over 10-1 as a class tomorrow. Again, you can either code along or watch and then go through it at your leisure. Finally, for 10.2, you are to create this one. I'm going to let you give this one a try yourselves. What is this? Well, notice we have 1, 2, 3 group boxes. The first group box has 3 radio buttons. The second group box has 3 different check boxes. The last group box has 3 labels and 3 text boxes. All right, if you want a clear button here, you can. Otherwise, just set it up the way they've got it set up. All right, so for instance, again, $6.95 for a hamburger, 75 cents for lettuce, tomato, and onions, 75 cents for fries. So $6.95 plus 150 is $8.45. 845 times the tax rate, I think they said of 8% or 7 point something. That gives you 65 cents and your total is $9.10. Hopefully that's straightforward enough. Then for 10.3, all they do is they ask you to add another form that only has this in there. So it's real simple. 2 buttons, an OK and a cancel, 1 label, sales tax percent, and 1 text box. So if I come in here and I change this sales tax percent to 10 and I click OK, then instead of this being at 7.95%, it should be at 8%. That's all. All right. Now, when you look at this, wait a minute, you're wrong here. This is a different program. Yeah, it is. But all you have to do, you can do that program if you want to, or you can just go and add this sales tax form to this program right here. That's probably easier and it's less work for you to do. So, because I have 1 more minute and I'm going to try to get you out of here by 9:30, let's say 9:32 at the most. All right, but let me go in here and do one last screen share, change, and I'm going to go to here. So your homeworks then. Chapter 9 labs, nothing. Chapter 10 labs, there are 2 of them. The superheroes one, which we will do as a class. The job database, which you will do on your own. The part 2, the new labs, nothing. Finally, again, for the extra exercises for chapter 9, both of them, you will do the calculate reservation totals on your own. All right. We will do the work with strings tomorrow in class. For chapter 10, all right. Convert lengths, we'll do that tomorrow in class. For the 10.2, you will do the process lunch on your own. For 10.3, rather than doing that one, I'd want you to add a second form to this application right here. And I'll let you work on that on your own. You still have to do all 3 of the written tests. So the written test for 9, 10, and 11. And again, last thing I'm saying, you are being given 2 lab periods, 2 full lab periods this week. That is 3 hours and 50 minutes at a crack, which means 7 hours and 40 minutes. In addition, it is now 9:30. You get 2 hours and 20 minutes today, or 2 hours and 25 minutes. That's 10 hours of lab time right there. Plus, if we finish early at all on tomorrow. So you should have plenty of time to do those problems. All right, that's all I've got. Hopefully, if you've got questions, Grant or anyone else, you will get a hold of me as soon as possible. But with that, all right, it's 9:31. I will see you tomorrow morning at 8:05. Have a good day.